This is the Mechanics Homework Booklet, question 19. In this question we're looking at the car that raised the world land speed record in 1997. The mass of this car was 1 × 10⁴ kilograms. A 12-second run by the car may be considered in 2 stages of constant acceleration. Stage 1 was from 0 to 4 seconds and stage 2 from 4 to 12 seconds. The writer of this question is actually being very helpful. The writer is trying to draw your attention to a number of key points. There are 2 stages to this journey, each with constant acceleration. That means that within each stage you may apply your equations of motion, but be careful not to try to apply them over the whole journey at once. Part A. Again, a helpful point here. It clearly says in stage 1. The car accelerates from rest to 44 meters per second in 4 seconds. You are asked to calculate the acceleration produced and the force required. So you can state acceleration is rate of change of velocity. So the velocity changes from 0 to 44, a change of 44 meters per second in a time of 4 seconds. That leads you to an answer of 11 meters per second squared. Secondly, you want the force required. So force is mass times acceleration, and having worked out the acceleration, you can multiply it by the mass given in the question to obtain an answer of 1.1 times 10⁵ newtons. Notice in both these stages I've been careful to include the units, and also in this last stage I have used correct standard form, placing the decimal point after the first digit. This is better than writing, for example, 11 times 10⁴. Next, you are told that you're looking at stage 2, and the car continued to accelerate so that it reached 280 meters per second in a further 8 seconds. This is where you're having to read the question carefully to interpret it correctly. So once again, you're asked for acceleration. Acceleration is rate of change of velocity. I've just written it slightly differently this time. So the final velocity is 280 meters per second, but the velocity at the beginning of stage 2 was 44 meters per second. This gives a change in velocity of 236. That change occurred in a time of 8 seconds, leading to an answer of 29.5 meters per second squared. Next, you're asked to calculate the distance travelled by the car from rest to reach a speed of 280 meters per second. By this stage, you should be very well aware that you are working with 2 stages to this journey. You must do 2 separate calculations using your equations of motion because you had 2 different values for acceleration. I've selected the equation s equals a half u plus vt. So we have a half of the initial and final velocity for stage 1 multiplied by the time for stage 1, and the same process applied for stage 2, giving 2 separate answers for the distance travelled, which we then finally just have to add together for the overall answer.